Hi guys, welcome. This is a video explaining why these two diagonals of a given rectangle bisect each other in the center of the rectangle. So I'm not going to go over Pythagoras or slope concepts. No, let's just take a different approach. I'm going to assign lengths, of course, to the width and height of the rectangle. Yes, and what this means is that for any rectangle with width of x and height of y, its middle point is going to be located at x divided in 2, y divided in 2, which is nothing else than this coordinate here. Okay, so with that in mind, how do I show that these two diagonals also intersect in that specific point? So let me just take this rectangle apart and let's remove its top line. And now it comes to light, like these two triangles become more evident. This one, right? And this one. And they're kind of overlapping, at least in this bottom line. They're kind of overlapping, and we know that they also share the length of these vertical sides, and they're practically sharing also the bottom line. So we can say they are equal. And yeah, mathematically the definition of equal triangles is not like this that I'm giving you. They need to fulfill some specific criteria, but let's just forget about the math for a moment. Let's say you just look at this. Practically we have kind of this is what we have, and this is this is going to be y, and this is going to be x, and this is going to be a distance of whatever distance. Let's put d. So just because the x, let me just copy it. Just because the x changes the direction, does that make this line longer or shorter? I mean, the distance between this point and this point is going to change? No, it's not going to change. So these triangles are completely equal, but the trick is not only in the two same sides of these toy or whatever you want to call it. If you're like a boy or a kid trying to send a ball down the ramp, let's assume it is a toy, but you're just placing it like looking into the opposite direction horizontally, but it's the same lengths and also the same disposition of them, because if I cannot assume the triangles are equal just because they share the two same lengths. What if I just take this line? Let me just okay, this is not letting me rotate it, but let's just assume, for example, this line is also, it has the length of y. This is the y rotated. If I place it here, now the length of this distance is going to change. So there's also another factor that leads us to think or to conclude that these two triangles were the same, and it's the angle between them, the angle between these two sides. So it's the same angle, and that makes our triangles identical. So do they share that angle? Yes. They both share this 90 degrees angle, or not share it, but they have the same 90 degrees angle. Also share this side and share these sides lengths. So that's it. That's the proof. It's just that it's not so evident. So if now I know that these two triangles are equal, right? These two that were overlapping each other like this, but I move this one just at the front of the left one, and I put them onto put them over the Cartesian plane. I can say that this specific point where they are touching is going to be x, right? Because it's just the length of this bottom line. And as they are equal, this point here is going to be twice x. Okay? And not only that, I can say that if I want to think about the middle, right? Doing this that I'm this drawing here, look at it. When I try to go here, it's like doing this. It's like if I were doing this in the rectangle, just in the middle, trying to get the middle point, which I know is located horizontally at x divided in 2. And as these two triangles are the same, then this middle horizontal point will be located at x divided in 2 plus x, which is nothing else than 3 times x divided in 2. Okay, so now we have the coordinates of the middle horizontal points for both of the triangles, and I'm just ballparking here because guess what? Yeah, they are the same triangle. They're practically the same triangle, so I can know that if I am at the middle point horizontally of this triangle, its y value is going to be the same y value that this triangle has for the middle of it, because they are the same triangle. So these two points right now, they are not equally located in the x-axis. Horizontally they're not the same, but vertically they are in the same place. So the y value for these 2 points is the same. I'm going to call this triangle right triangle, and to this one left triangle. And my left triangle, its middle point, this one that I'm trying to track, is going to be x divided in 2 yi, whatever that y is. We don't care about this right now. And the right triangle middle point is located 3 times x divided 2, but at the same y. Okay, and that's it. These 2 points, I mean, this one is this one and this one is this one, but that is not what we had at the very beginning. What we had, the situation we had, it was that these 2 triangles were overlapping. So how do I take them back to overlap? I mean, I have 2 ways to do it. Overlap this one over this one, or this one over this one. So I'm going to go with this one to the left. And how much do I have to move this triangle to the left to overlap the other one exactly in this bottom line? Well, it's very simple. This x has to be here, or this point of this triangle is going to have to be on 0. And instead of this corner being in 2x, it's going to have to go to x. So it's practically moving all of its points by a factor of x to the left. And what this point is going to suffer is a change, because now it is not going to be here. The right triangle middle point is not going to be there, but it's going to be there, but shifted x units to the left. And how do you shift it? Well, to its x value, or the x coordinate, you're going to subtract x, because that's where this point is going to end up. And it's going to keep its same y value, because we are translating it horizontally, never vertically. And guess what? This subtraction here gives us x2 comma yi, which means that when I overlap these two triangles, those two middle points are on the same place. So now I know that they intersect at this value, at this specific value. They're intersecting on the x, x divided in 2. So we are close to there, but what is missing? I also need to show that the y is going to be, the y intersection is going to be here. And how do you do it? Well, you can just do the same, but relative to the vertical axis. Here we were moving horizontally and overlapping the triangles horizontally, but now let's just take them. So we know they overlap at this point, on this point, right? So let's just find the y-axis, the y-axis value of intersection. I'm going to put them again, one over the other in this case, but you know that this value, this vertical coordinate here is going to be, twice y, right? And this one here is going to be y. Why? Because this and this, both of them, their lengths are y. We just apply the same. What do I have to do, or how was the original disposition or location of these two triangles? In the rectangle they were here, so this corner was matching with this one, and this corner was matching with this one. And if I take my triangle from here and I need to make those corners match, right? This corner with this corner, I'm gonna have to shift or move this triangle downwards by y units, right? So it's practically the same. I'm going to subtract y from it, and I'm assuming, of course, this is going to be y over 2, 3 times y over 2, and this one is going to be at y over 2. So what's gonna happen with this point, which I already know its x coordinate is going to be x divided in 2. So this point is practically, both of them are located at x divided in 2. But once I overlap them back, after this subtraction, after subtracting y from this triangle, this point here is going to turn from x divided in 2, 3 times y divided in 2 is going to turn into x divided in 2, y divided in 2, which is where this middle point of the first triangle is located. So that means that both of the coordinates fulfill to be in the center of the rectangle. And that's practically it.